Don't you know?
So Erin, review question 7 says, diet books say that you can lose weight by drinking ice cold water. Why would they think that?
I don't know, I actually have some problems with that question.
Okay, that is not uncommon, so don't worry. Kristen?
Because you use more energy to get the water to body temperature, so you burn more calories.
Right. So your body is always a constant temperature, 98.6-ish, right? And that ice cold water goes in, you're just like a calorimeter, right? You have to bring that up to your body temperature. So all the energy the water gains, you lose. Losing energy burns calories, right? So later we'll see just how effective that might be. All right, so Erin, number 8, examine the heating curve for this unknown substance. So what do you see when you look at the graph?
Some,
Go ahead.
it boils at about 55 degrees Celsius.
Okay, so it boils at right about 55 degrees Celsius. Now, significant figure-wise, you can only read one significant figure between the lines. And since there's a line at 50 and a line at 60, and those are just one significant figure, you can only go to the ones place on that graph. So it's not 55.0 or 56.0, it's just 54 or 55 or 56. Probably those are the only 3 answers, degrees Celsius, that would work out there. Okay, so Maddie. The specific heat of iron is roughly 3 times that of gold. Equal masses of gold and iron start at room temperature and heat is added to them at the same rate for the same amount of time. When it's over, the gold's temperature has increased by 900 degrees Celsius. What is the temperature increase of iron?
270 degrees Celsius.
Okay, how did you find that?
I did this one on the board. I have a dry erase board in my room, so I don't have the work in my notebook. And I did this, like,
A long time ago.
yeah.
Okay, so let's think it through. If they're the same mass and they're heated with the same amount of heat at the same amount of time, and we know that the specific heat of iron is 3 times that of gold. So when you have a big specific heat, will your temperature change more readily or less readily?
Less.
Yes. So what that tells us is if the specific heat of iron is 3 times bigger than that of gold, then it's going to essentially change at a rate 3 times, the change in temperature will be 3 times less because it's got a bigger specific heat. So what's 3 times less than 900 Celsius? Oh, I see what you did. You accounted for room temperature, didn't you?
Did I?
Yes. Okay, so here's the thing. It's not like it started at room temperature and it increased to 900 degrees. It increased by 900 degrees. So delta T is 900. It's not 900 minus room temperature, which is what you did to get 270. So if you just say delta T is 900 and then you divide that by 3, what would you get?
300.
300 degrees Celsius. So yeah, I get what you did.
Okay.
But delta T is 900, not 900 minus some estimate of room temperature. But that was good thinking. You were definitely using your brain. Jolene, why should a calorimeter be made from an insulating material?
So you don't receive external heat.
Or you don't want any heat to get in, but you also don't want
Heat to get out.
heat to get out. Yep, no heat should be lost, no heat should be gained by the contents of the powder. Lily, what's our first practice problem this week?
So number 5.
Number 5. Okay. So how many joules does it take to heat up 15.1 kilograms of glass from 15 degrees Celsius to 45 degrees Celsius? So if we want to know how many joules, what's our goal?
To find heat.
Okay, so Q of the glass is our goal. So I always write that down right at the beginning of the problem because then I don't lose track halfway through all this stuff and forget what I'm doing. So what else do we know?
We know that heat equals mass times specific heat and this change in temperature.
Okay, so we've got an equation. Alright, do we know, so we want to know Q, do we know mass?
Yes, it was 15.1 kilograms, which comes to 15,100 grams.
And C,
No idea what I've done.
for the sea of glass, you probably had to look in a chart.
Yeah, 0.8372. And should, okay, I rounded my grams to 20,000. Should I not have done that? Like for significant
No,
figures?
because when you convert 15.1 kilograms to grams, you can keep what you have. So if
Okay.
you've got 3, keep them, and you still have 3.
Okay, I think I was thinking because I multiplied it by 1,000, which would only have one.
Try to not round till the end unless
Okay.
you have a moment where you have to add and subtract, then you have to kind of round it at that point. But
Okay.
since we're only multiplying and dividing here, don't round, keep it right there.
Okay.
So we'll recalculate.
Yeah, my numbers might be skewed.
Yeah. And what's our delta T? Do we have it?
30 degrees Celsius.
Okay, so it started at 15 degrees Celsius, ended at 45 degrees Celsius. So what's wrong with my significant figures if I write that?
Oh, there's only one sig.
So it's heating up. Right, this looks like 1, but really it's 45 minus 15, so that should be 2. So I'm just going to underline this 0 to show that it's significant, because both of these are significant to the ones place. So my 30 really is significant here in the ones place. You could also write 30 with a decimal degrees Celsius, or you could write 3.0 times 10 to the 1 degrees Celsius. But scientific notation inside a math problem overcomplicates things, so I usually do that. You can do what you like, just show significance where there is significance. And that right there has 2 significant figures. So our Q is our unknown, our mass. And you need to show work on the test just like this, with all the units, even though they're kind of a pain to write out. And then plug that all into your calculator, and what do we get?
Three point 8
Yep.
times 10 to the 10 to the 5.
Tell me real loud.
3.8 times 10 to the 5
Good. And what's my unit?
joules. Sorry.
Okay. And she kept 2 significant figures, which is just right, because this has 3, this has how many? 4, but this, with that decimal there, only has 2. So when we multiply, we have to keep the least, that's 2, so we keep 2, 3.8 times 10 to the 5th joules. So that's a big chunk of glass. It takes a large amount of energy to heat up. Okay. Get another problem right here. Jenny, is your homework in folder? I hope. We've got number 6 here. 124.1 grams of an unknown substance absorbs 50 kilojoules of heat and increases temperature by 36.3 degrees Celsius. What is its specific heat? So, we're gonna use, what's our goal, Jenny?
Our goal for which problem?
6.
6.
And so,
The specific heat.
okay, so I'm gonna put a big question mark next to specific heat. And what is our heat? Q.
124.1 grams.
Okay, that's mass.
Yes.
What's
Oh,
the heat?
you want something else?
Heat.
Oh.
Q. Heat.
I think I did something wrong.
What do you have?
I can't find stuff. Whatever that says.
Well, what does it
I
say?
can't read my handwriting.
Well, the problem says, what, 50.0 kilojoules of heat. So kilojoule means you multiply by 1,000 to find joules, right? So we'll move our decimal 1, 2, 3 places, and we'll get 50,000 kilojoules, 50,000 joules. But significant figure-wise, how many should I have? This looks like 1, but I know I should have, how many? 3. So this digit is the last significant digit. And you could use scientific notation there. You could say, what, 5.00 times 10 to the 4th joules. I'm going to underline that because it's easier for me. And what is my change in temperature? It increases its temperature by 36.3 degrees Celsius. All right, so what do I do now, Jen?
You divide the 50. 50 or 50,000
It's
or
50,000.
you wrote like 3 things at the same thing on the board. Okay.
Yeah, because you can express your significance.
That one. You divide that by the mass and the delta T.
All right, so this is just a rearrangement of Q equals MC delta T solving for C. So C equals Q divided by mass times delta T. And I did that. And so when I do the math, I've got 3 significant figures here, 4 here, and 3 here. So I should keep 3. And then what do I get? I don't actually have an answer. Oh, there it is.
11.1 joules per gram degree Celsius.
Good. Okay. And Liam, would you rather write or talk?
Talk.
Okay. I think I'm actually going to skip number 7 because it's very similar. Did anyone have any trouble with, well, no, let's don't skip. I know practice problem 10 has a YouTube video doing it. So if we don't get to practice problem 10, you can definitely watch it and correct your work if you have any mistakes. But we'll do number 7. So, talk me through. A 245 gram piece of copper at room temperature loses some heat. What will its new temperature be?
Do you want my answer or?
I want you to talk me through. Q equals M, C. And in this one, we actually have to consider all the information about the temperature. It doesn't just give us delta T anywhere.
Yes. So to find that, the delta. Yeah. Okay. So to find the delta T, we rearrange the equation. Q equals M times C times delta T to get delta T equals Q divided by M times C. And then plug in all those numbers.
Okay, tell me the numbers.
So, for the Q, it's 456.7 joules. Mass is 245 grams. And copper's specific heat is 0.3851 joules per grams times whatever.
Joule per gram degree
That thing.
Celsius.
Yeah.
This is the
Okay,
5.
do we have
Okay.
a final or initial temperature?
When I was doing it, is the joules supposed to be a negative because it like lost heat?
Yes.
Okay.
Because it says
Yes,
it lost
I have that.
heat.
I did not see that. Okay, I have that. Okay. So then the answer is negative 4.84 degrees Celsius.
Okay,
Then-
so we've got a delta T.
So then we take the equation delta T equals the final temperature minus the initial temperature and change that around. So the final temperature equals the delta T plus the initial temperature. So that's 4.84 plus 25 or negative 4.84 plus 25 equals 20 degrees Celsius. Hopefully.
Tell me again.
Negative 4.84 plus 25.
Okay. What's the actual answer? So I don't have to
The
think.
actual answer is 20 degrees Celsius.
20, okay, because you
Point-
have to round to the ones
yeah.
place. So, but it's two significant figures.
Yes.
So let's do it out. So we've got 25 minus 4.84. This has significance to the ones place, this to the hundreds place, but we have to take the worst situation possible. So we have to round to the ones place. But when we do the subtraction, we get this. But the 1 can't make the 0 go up, so we just round to 20. But the ones place is significant, so we have to somehow show that by putting a decimal point or using scientific notation or something. So our final temperature is going to be 20 degrees Celsius with two significant figures, and that's what I got. Good. All right, Austin. Let me erase. Everyone have that? Need a minute? Chemistry at the speed of light, because 2 hours really makes it easier. I super appreciate you guys all getting up so early and doing this, because we can actually almost always get through almost everything.
Are we almost done what I have to film?
Nope.
Because,
Is it dying?
well, the battery thing is flashing.
Okay, well,
So I
let's
don't
change
think that's a good
batteries.
thing.
You can hit stop and we'll change batteries in Austin.